Okay, fine. This is lecture number 2 for the subject of communication system. हमने last lecture में क्या देखा था? Do you remember? Third. Right, third one. So we had gone as of now till अभी तक जो हमने देखा wired communication, हमने देखा wireless communication system. We had a brief idea what modulation is. We had an idea what communication is. And some basic difference आपने कुछ किया था खुद क्या assignment क्या था different type of wires that we have seen what are possible वो आपने देखे very nice ठीक और शायद मैंने ये कहा था difference between analog and digital नहीं अच्छा ठीक ये आप देखिए ये जो assignments मैं आपको दे रहा हूँ ना ये आप साथ साथ नोट डाउन करते जाएंगे अपनी ही नोटबुक पे ठीक है अपनी ही नोटबुक पे ये करने हैं ये ज़्यादा एक पेज का होगा 1.5 या आधा पेज या आप तक लेकिन दरकार है कि ये उसी टाइम पे करना है क्यों बिकॉज आई कैन ये तो पता है आपको असाइनमेंट वगैरह वी हैव मार्क्स फॉर असाइनमेंट्स एंड ऑल वी नो दिस ऑल राइट एंड आई एम गिविंग यू स्मॉल असाइनमेंट्स लाइक टुडे आई विल गिव यू वन मोर व्हिच इज वेरी स्मॉल वन पेज और हाफ पेज बट इट हैज टू बी डन एट द सेम डे दैट इज इंपॉर्टेंट व्हाई बिकॉज आई मे चेक इट आइदर नेक्स्ट डे इमीडिएटली आउट ऑफ सरप्राइज or I may check it any given day. So in order to get your marks in continuous assessment, you have to assure your attendance every day. Or else, in case if you have something very important, unavoidable, you can just give me a call. So my number is this. I have this problem. I may not come tomorrow. Even if there is a probability of you not coming, I may not come tomorrow. You get my point? So what will happen by this is that say if I had planned to go for continuous evaluation on that day, I will consider you. Okay? You can tell me, sir, I made a call to you and so I have a valid case. I'll say okay. But for those who remain absent as it is without any intimation and all that, they will be penalized for that. Not by me, but by the system itself, because they will lose those marks. So all these assignments are important. All these have to be on your notebook itself, which you carry every day to your class, so that they remain as a class notes for you. At the time of exam, you don't have to scatter yourself, get this thing from there, that you have everything in one notebook. More importantly, this will assure your presence in class every day. And if there is some problem or whatever, you can call in on that day. I had some issue, or tell someone to call on your behalf. That's just okay. If it is an emergency. Maybe you cannot call, but by default you should call yourself. Okay? Fine. Next up, first write the assignment with the assignment. Assignment is differentiate between analog and digital systems. Differentiate between analog and digital systems. Okay? Systems या signals दोनों या दोनों में से एक हाँ दिया था मैंने एनालॉग एंड डिजिटल सिग्नल्स आप सिस्टम का पेज रख लीजिए ये भी एक आधा पेज रहेगा नॉट अ प्रॉब्लम ठीक है you can please फ्रंट पेज पे नोट डाउन पे आप नोट डाउन कीजिए मैं कौन कौन सा असाइनमेंट दे रहा हूँ वो आप अलग ना फ्रंट पेज पे नोट डाउन कीजिए ठीक है जो नहीं आए थे वो देख लेंगे उनके मार्क्स वरना कटेंगे ये उनकी जिम्मेदारी है हम उनके नौकर नहीं है ठीक है वो अपने आप के खुद नौकर है ये एटेंडेंस का पेज है मुझे लास्ट में याद दिलाइएगा Okay, anyways, yeah, we are through an important topic today, very important for the understanding of this subject, which is, आप लिखिए heading लिखिए, heading means basics of Fourier transform. Although we won't deal with the concept of Fourier transform, but yes, some basics ought to be needed for understanding modulation. What are they? Let's go through them. Let's assume we have a time domain signal given by x of t. Let's assume that we have a time domain signal. Time domain समझते हो ना? जिसको हम टाइम डोमेन में रिप्रेजेंट कर रहे हैं ठीक है if we go for the Fourier transform of this signal we will get a signal represented as x of f, capital X of f. And this is the Fourier transform of the signal x of t. Now this Fourier transform signal will have two parts, so I can get information about two things from this transform. One, I can plot mod of x of f versus f, and this plot is called as amplitude spectrum. Or else I can do one thing, I can plot my phase, or I would say angle of x of f versus f. This type of plot is called as phase spectrum. Jaldi settle down. Okay, you got my point? Now you listen. If I have a signal x of t, I go for the Fourier transform. Fourier transform is a tool in communication where you want to see कि इस सिग्नल के अंदर कौन कौन से फ्रीक्वेंसी कंपोनेंट्स है, इस सिग्नल के अंदर या इस सिग्नल का नेचर कैसा है फ्रीक्वेंसी डोमेन में. There is something called as time domain representation. There is something called as frequency domain representation. That's right. Like for example, your representation in your class is like this. But when you go into your buses, you get transformed, and when you reach your home, maybe you transform. Your representation is different, right? You get my point? You hear you are very formal, this and that, and there you know your pajama is on your head, and your t-shirt is in your maybe feet, like that. So you get transformed. So likewise, we have time domain representation and frequency domain representation. When you have the variable t, it is time domain. When you have the variable f, it is frequency domain. Now, if I plot this x of mod of x of f, listen to me. When you come late, you should not discuss anything with your friends. Even if you have missed something, keep that page as it is. Start from where you have left. Okay? So when we plot mod of x of f versus f, it is called as amplitude spectrum. And when we plot, listen to me, and when we plot angle versus frequency, it is called as phase. Is that clear? Absolutely clear. How do I find this? Now the question is, what is the formula to find x of f? What is x of f? X of f, Fourier transform. Mod of x of f versus f is amplitude spectrum, and that is phase. Anyways, how to find x of f for a signal? There is a small little formula to find the Fourier transform, which is x of f is equal to minus infinity to infinity x of t into e raised to minus j 2 pi ft into dt. This will provide us the converted version, or I would say the transformed version of a particular signal. So say for example, if I have a signal x of t and I go for the Fourier transform, say for example, my transformed signal will look like this, and rather I would say the amplitude spectrum of the transformed signal, because I am assuming that this is mod of x of f and this is f. So what is this plot telling me? Amplitude spectrum. Go to the word amplitude spectrum. It tells me that whichever frequency components are present in the signal, what is the amplitude of respective frequency in this signal x of t? I repeat. The amplitude spectrum tells me that what is the different what is the different intensities of each particular frequency component present in the signal x of t. Because x of t is the original signal, we have taken its Fourier transform, and we come to know about the different frequencies, or rather I would say the amplitude of different frequencies in this signal. Okay. Now, have you gone through that harmonics and this and that in your 12th class? Harmonics होता है ना कुछ चीज़. Harmonics. What are harmonics? They are basically amplitudes of different frequencies, and maybe they just kind of continue repetitive harmonics and all that. So well, that's a different subject, anyways. But here we need to understand this. Is it clear? That's enough for me if it is clear. Okay, we can write one line. Fourier transform is used. Fourier transform is basically used. Fourier transform is basically used to find frequencies contained by the given. थोड़ा fast लिखो. Contained to find frequencies contained by the given time domain signal. Contained by the given time domain signal. By the given time domain signal. Okay? Let me erase this all in order to understand it better. Let's take a simple example. What Fourier transform will do to that signal and what will it generate. Okay? Let's take an example. For example, we have a signal x of t contained, which is given as a gate pulse. This is known as gate pulse. This is minus tau by 2. This is tau by 2. Okay, like plus. Let's say the amplitude of this is any amplitude. This is time domain, right? This is t axis, and this is the amplitude axis. So let's say my x of t is this. Now, if I ask anyone, can you come over the board to find x of f? Can you find x of f? Okay, just tell me. बस आप बताओ मुझे. आप बताओ. x of f कैसे ढूंढूंगा मैं इसको? शाबाश. बस ये बताएगा. आप इसको मत बोलो. आप अपने साथ अंदर से बोलो. माइनस में इनफिनिटी. into x of t. Okay, let's say x of t. ये बोला. x of t into e raised what? Minus much? 2 pi f. Then f by f into t into dt. So this happens to be the general formula. Now when I apply this to this signal, eyes on board please. When I have to find the Fourier transform of this signal, here minus infinity and infinity will get converted into minus tau by 2 and plus tau by 2. Because for this signal infinity is that. मतलब छोटे बच्चे को हम देंगे 100 रुपए, वो तो अमीर हो गया. आपको 500 देंगे, यार कुछ नहीं है जेब में. So for that kid that is infinity. So likewise for this signal, because का nature ही ऐसा है, इसके लिए minus infinity ये माना जाएगा plus infinity ये. इतना एक्सप्लेन करने की जरूरत नहीं थी, but just for the sake of. So this is minus tau by 2 and this is tau by 2. आप बताइए जरा. आप बताइए. हाँ. xt के बदले क्या लिखूं मैं? आप वो है. Okay, your answer, wrong answer. Come on. Zose. Shaba, this is the correct answer. It has to be A. Because in this region, minus tau by 2 plus tau by 2, the signal is constant. It is not changing. So the value of x of t has to be A. And I will go for e raised power minus j 2, wait a second, 2 pi f t. Okay? Into dt. Now I will integrate. Integrate क्या टाका सर नहीं? ये मुझे टाका है सुबह वापस सुबह 10 मिनट ये. Yes, one to time integration शामिल. नल कुछ वीडियो का. So when I integrate this, it will be a ये वाली term यहाँ पे into e raised power minus j 2 pi f t और जो आपकी जो दो क्या बोलते हैं इसको लिमिट्स होंगी tau by 2 and minus tau by 2. So once I will put the limit this and another time this, so final answer will be my final answer would be something like minus a divided by j 2 pi f into e raised to power minus j 2 pi f. What is the limit first time? Instead of t, I will write tau by 2 minus e raised to power plus j. Why? Because for the second case it is minus tau by 2. So minus minus becomes plus 2 pi f into tau by 2. So this should be your final answer as of now, right? सही है कि गलत है? चेक करो जरा बेटा, सही है गलत? सही है। अब हम इसको इरेज करेंगे। So when this is done, we know that a signal which is represented as e raised power j of say theta or x, whatever you want to, minus e raised power j minus of j of x divided by 2j is nothing but it is a sine. Exactly right. Okay, हम चुनाव करते पूर्ण याद just say. Now let me try to convert this part into this. How? What will happen? So end result will be minus a divided by j 2 pi f into e raised to power minus j because 2 और 2 कैंसिल आउट हो जाएगा। सो x कितना है? x क्या है यहाँ पे? दिस इज नथिंग बट a डिवाइडेड बाय पाई f। ये वाला 2j इसके साथ जुड़ जाएगा, ठीक है? इनटू साइन ऑफ पाई f। इज दिस करेक्ट? yes or no? Yes sir. Is this correct? चलो शुक्र। So that means we are reaching towards a sine signal. Okay. But we will slightly play with the signal. Huh? माइनस गया ना eyes on board please. That's why it has to be from this side. That's why ये minus अंदर है। Anyways, you can figure. So यहाँ पे लिखिए multiplying by, sorry, multiply and divide by tau. Multiply और divide करेंगे tau से, तो end result आएगा a divided by pi f into tau into wait a second, multiply and divide by not tau, multiply and divide by जो ये साइन का एंगल है, rather multiply and divide by theta, multiply and divide by theta, what is this angle? It is pi f tau. Okay, so what will happen? pi f आप अपनी जगह रखिए, sin of pi f tau divided by pi f into tau. Visible? कहाँ visible? Okay. Pi f by tau, huh? Multiply and divide by pi f tau. अरे कर रहा हूँ ना, चलने तो दो। So what will happen is ये आपका पाई है Fourier कैंसिल आउट हो गया। फिलहाल ये जो आपका ये वाला सिग्नल का पार्ट बचा, there is a signal, I don't know how many of you know that there is a signal called as sync. Have you heard of this? Say I have sync x. Your sync x is equal to sine of say pi x divided by pi x. Your sync x is equal to sine of pi x divided by pi x. मतलब इसमें भी sin theta divided by theta, ठीक है? Sin theta divided by theta is called your sync function. इसको याद रखना. Please remember this and search about this function. ये है optional assignment. Sync function के बारे में थोड़ा सा देखिए. It's optional. It's necessary. Sync function के बारे में थोड़ा सा देखिए. ठीक है? So what happens is मेरा जो end result आया, मेरा ये वाला सिग्नल कन्वर्ट हो गया इनटू ए सिग्नल. एग्जैक्टली ये वाला फंक्शन जो है ये कन्वर्ट हो गया इनटू, यहां से आइसोबोर्ड यहां से मैं यहां जा रहा हूं, सो ये कन्वर्ट हो गया इनटू ए टाउ इनटू सिंक एफ टाउ. And this is nothing but the Fourier transformed version of the signal. And if I draw the nature of this signal, how does it look like? It will look like this. So Fourier transform of this signal will be like is it visible? So this is 0, this is 1 by tau, this is 2 by tau, this point is 3 by tau and so on. Likewise this is minus 1 by tau, this point is minus 2 by tau, this point is minus 3 by and so on. ठीक है? तो इस सिग्नल का जो टाइम डोमेन में था, इसका जो फोरियर ट्रांसफॉर्म बना वो कुछ इस तरह से बना. These frequencies -1 by tau to -2 by tau are called as negative frequencies. Components are negative frequencies. The intensity of the frequencies which are on the negative side is in a way, and we can call that negative spectrum, or else it is better to write negative frequencies, and they will always be a mirror image of the positive frequencies. ठीक है? आप कोई भी अगर स्पेक्ट्रम हम देखेंगे, जो स्पेक्ट्रम या कुछ आगे जाके, अगर आपके पास पॉजिटिव को आपका पता है तो नेगेटिव का बस मिरर इमेज होगा. ठीक है ना? Is that okay? So very important point coming up here. And all these, eyes on board please, all these are positive frequencies. By the way, this will extend to infinity, this will extend to infinity. Now we have a problem here. What is the problem? The problem is that I had a very small signal or a feeble signal in time domain, which was from minus tau by 2 to plus tau by 2. Now when I convert the signal into frequency domain, what happens is that I have a signal whose bandwidth is infinity. because it is going, as I said, it extends. ये एक I would say oscillatory signal है, but damping signal है. This goes down. This goes down. As you can see, amplitude is high, then lower, but it will go to infinity before it dies. ठीक है? So therefore, if I try now, the most important point, eyes on board. Now therefore, if I try to transmit this signal through a wire or through an antenna, how much is the bandwidth? As of now, it is infinity because it goes to a very large extent. I'll just repeat. How do I find the bandwidth? So you write general formula for signal bandwidth. General formula for signal bandwidth is equal to highest positive frequency minus lowest, lowest, no, lowest positive frequency. Okay, Moise, आप बताओ, what is the highest positive frequency here? No, 0 is the highest value by the way for time. ठीक है, इसमें 0 ठीक. Okay, what is, sorry, 0 is the lowest. 0 is the lowest. Okay, which one is the highest positive frequency? Exactly right. Because frequency मतलब मैं कहता हूँ इस सिग्नल में ये frequency है. Eyes on board. When I say that this signal contains these frequencies, that means there exists a non-zero value at these particular frequencies. I repeat, when I say that a signal contains frequency XYZ, it means that when I see the amplitude spectrum, there exists a non-zero value at these particular frequencies. Then only say I can that these frequencies exist in the signal. If the value of the at that particular point of value of amplitude is 0, that means those frequencies are not contained in that signal. Do you get my point? You don't get it, but you will get it soon, right? So what I mean by this is highest positive frequencies and highest lowest, maximum value positive and maximum value lowest. That means my highest positive here is nothing but infinity, and my lowest positive is 0. So what is the bandwidth? It's a striking truth. The bandwidth is infinity. Okay? So the bandwidth for transmitting such a signal will be infinity. The bandwidth for transmitting such a signal would be infinity. Therefore, we realize that transmitting such a signal as such is not possible. Therefore, we realize that if we try to transfer this signal, it is impossible. Nearly impossible, straight away impossible. वही बात फिर से जब हमने कहा था हम एक simple signal will try to send a simple unmodulated signal. What was the problem in sending an unmodulated signal? Last class. There was a problem when we tried to send an unmodulated signal. What was the problem? The signal is louder, please. Wrong answer. You know what is modulation? You remember wireless transmission? In wireless, we do first modulation. Remember? No. Okay. Zua, Manu. Do you know what is modulation? If I try to send a signal without modulation, what will happen? What is the problem? Interference. Okay, next. I am saying without increasing frequency, if I send, what is the problem? The problem is, go on, anyone. Antenna height is too large. I told you that if I am trying to send a signal for 10 kilometers, if I try to send a signal for 10 kilometers without modulation, I would need an antenna of height of maybe 9 kilometers. Right? Isn't it better if you reach 9 kilometers, go walk 1 kilometer more and give the message and come back? Get the point? So without modulation, we don't go for like wireless transmission. We go for likewise. If we try to send this signal, such a signal, what will happen is our bandwidth requirement is infinity. Is that possible? That is not possible. So we have a problem. Now we want to find a problem to the solution. What we do is we go for a term that is called as next heading, band limiting of a signal. Look, when I say next heading, I say this just because you have a very clear notes. You know what is the heading, and you should not lose the track of these headings in other lectures also. Ask your teacher, sir, is this the same heading or it is the next heading? Your teacher knows for sure, but it is you who have to ask him. Everyone may not tell you the heading. You just go on, because there are different styles of these, okay? But you are supposed to ask. Anyway, what? You want to take a breath? We can pause for a while if you want. ये जो ये ग्राफ हमने यहाँ बनाया पूरा, ये असली एम्पलीट्यूड स्पेक्ट्रम है, लेकिन फॉर दिस सब्जेक्ट विल जस्ट रेफर इट एज स्पेक्ट्रम. ओके, फॉर दिस सब्जेक्ट विल रेफर इट एज स्पेक्ट्रम. जब मैं स्पेक्ट्रम कहूँ आपको पता चलना चाहिए एम्पलीट्यूड स्पेक्ट्रम. फेज से हमें इस सब्जेक्ट में उतना ज्यादा मतलब नहीं है, ठीक है? So I will just use the term spectrum. S-P-E-C-T-R-U-M. Spectrum. अच्छा, ठीक है. आपसे क्वेश्चन पूछा जा सकता है, व्हाट इज बैंडविड्थ? बैंडविड्थ की डेफिनेशन एक छोटी सी लिखिए. द बैंडविड्थ, तो कैसे लिखिए? द बैंड ऑफ फ्रीक्वेंसीज, द बैंड ऑफ फ्रीक्वेंसीज, the band of frequencies allowed by a channel, the band of frequencies allowed by the channel, by the channel, a channel to channel, allowed by the channel without any attenuation, without any attenuation is said to be the channel bandwidth. Okay? Without any, okay, you don't know this, what it is. Without attenuation, A-T-T-E-N-U-A-T-I-O-N. Without any attenuation. What is attenuation? Anyone? Random guess. Raise your hand. Excellent, that's the right answer. Attenuation means stoppage. See? Without any stoppage, I mean stoppage for you, but for an EC student it's not stoppage, it's something else. Maybe it's like degradation of a signal by some external factor. Attenuate करना, इसको block करना, signal को attenuate करना. That attenuation can be controlled by various devices. Or I would say reducing the gain. इतने सारे definitions, but for you it is रोकना is enough. So, the band of frequency allowed by a channel without any attenuation is said to be the channel bandwidth. Ideally, for मिलेगा? Is said to be channel bandwidth. Repeat क्या करना है? Attenuation. The band of frequencies allowed by the channel without any attenuation is said to be the channel bandwidth. Do you get me? What is channel bandwidth? How do you pronounce it? Channel bandwidth. शाबाश. बस नहीं चाहिए मुझे. Channel bandwidth. Okay. You say ideally for ensuring that no information loss occurs. Ideally for ensuring that no information loss occurs, channel bandwidth should be equal to signal bandwidth. Channel bandwidth should be equal to signal bandwidth. अच्छा, वहाँ पे एक क्वेश्चन ये भी उठता है, सिग्नल बैंडविड्थ जो हमें अभी डेफिनेशन दे दी वो चैनल बैंडविड्थ की है, ठीक है? अब सिग्नल बैंडविड्थ हो गया, द फ्रीक्वेंसीज दैट सिग्नल बैंडविड्थ ये है बाय द वे. द फ्रीक्वेंसी कंपोनेंट्स कंटेन्ड इन अ सिग्नल इज द सिग्नल बैंडविड्थ. तो इसकी बैंडविड्थ कितनी है? इन्फिनिटी. यही से कंसेप्ट आया. तो चैनल बैंडविड्थ कितनी होनी चाहिए? अगर इन्फिनिटी नहीं हुई क्या होगा आप बताइए? अगर इन्फिनिटी नहीं हुई चैनल बैंडविड्थ, बाय द वे सिग्नल बैंडविड्थ क्या है? चैनल बैंडविड्थ क्या होनी चाहिए? मैं कह रहा हूं, मैंने अभी कहा चैनल बैंडविड्थ सिग्नल बैंडविड्थ के बराबर होनी चाहिए। हाँ बढ़ना हुआ ना। शाबाश। अगर नहीं हुई चैनल बैंडविड्थ तब ऐसे किया बकवास कुछ ना। मैं तो ये में हूं सॉरी लिखना मना लिखना। मैंने कहा जो किसी से क्वेश्चन पूछा कोई रीजन होता है, ठीक है? रीजन ये नहीं होता है उसको डिफेम करना। रीजन ये होता है कि उसको पता है उसका आंसर, लेकिन उसको खुद भी पता नहीं कि मुझे पता है आंसर एंगल। क्या होगा अगर इन्फिनिटी नहीं होगी? क्या होगा? समझ प्रिसाइज आंसर नहीं। मैं आपने कहा इन्फिनिटी होना चाहिए। अगर इन्फिनिटी नहीं है चैनल बैंडविड्थ तो क्या होगा? अब आप बताओ क्या होगा? यस और नो? हाँ आप बताओ, आप बताइए। आप नीचे देखने से कुछ नहीं होगा, मुझे तो भी आप आप बताओ। एग्जैक्टली राइट। मैंने तो अभी वो कहा ना वर्ड्स नहीं। आई वॉन्ट यू टू पे हीड टू व्हाट आई से, जस्ट व्हाट आई से। मैंने आपसे अभी कहा ना कि इंफॉर्मेशन लॉस नहीं होगी अगर ये बराबर, अगर आप बराबर नहीं होगी तो इंफॉर्मेशन लॉस होगी। दिस इज एज सिंपल एज दैट। क्योंकि कंसेप्ट नहीं था, ये बस अवेयरनेस की बात है। हु इज हियर? ठीक है ओके। therefore ओके हमने हेडिंग क्या लिखी थी? बैंड लिमिटिंग। ओके द प्रोसेस ऑफ डिक्रीजिंग, therefore ऐसे लिखी द प्रोसेस ऑफ डिक्रीजिंग। एक्चुअली आई वांट यू टू राइट therefore बैंड लिमिटिंग इज अ मस्ट। ठीक, क्योंकि या तो चैनल को इनफाइनाइट बैंडविड्थ देनी है, वो पॉसिबल नहीं है, या तो आप सिग्नल की बैंडविड्थ कम करनी है, वो पॉसिबल है। therefore बैंड लिमिटिंग इज अ मस्ट। अब बैंड लिमिटिंग क्या है? बैंड लिमिटिंग, डेफिनेशन ऑफ बैंड लिमिटिंग। therefore हटाइए। The process of decreasing the bandwidth of a signal, the process of decreasing the bandwidth of a signal from infinity to a finite value is called as band limit. ओ मैंने कहा ना मुझसे पूछो, इससे मत पूछो। आप जरा मुझसे नहीं पूछ सकते हो, मुझसे नहीं पूछ सकते हो। से ऐसे मना, मुझसे नहीं पूछ सकते हो। हाँ क्या चीज? मेरे मुंह में जबान नहीं है, क्यों माना? बर्ड का बनता। अच्छा फिर क्यों दाएं बाएं देखे थे आप? चलिए फिर आपसे सवाल है, चलिए रहने दीजिए, नेक्स्ट टाइम। द प्रोसेस ऑफ डिक्रीजिंग द बैंडविड्थ ऑफ अ सिग्नल from infinity to a finite value is called as band limit. Go with the marks. Now the question is how to do band limit. You might think very good. ये इसलिए जरूरी है क्योंकि जो हमने आधे घंटे से पढ़ा उसने बैंड लिमिट इसलिए जरूरी है बिकॉज अगर हम ऐसे बड़े सिग्नल को बेच देंगे ना, मतलब उसके लिए तो दुनिया की बैंड लिमिट इसलिए हम बैंड लिमिट कर रहे हैं। यू शुड ऑलवेज आस्क क्वेश्चन, दैट इज गुड। ठीक है, इससे थोड़ा क्लास का एटमॉस्फेयर भी हो जाता है कि अगर क्वेश्चन उतना इम्पोर्टेंट नहीं है मतलब क्या उस साल तो यू डोंट हैव टू बॉदर अबाउट इट, यू शुड स्टिल आस्क। ठीक है, लेकिन एडवांटेज क्या है आपको, आपके दिमाग से कंफ्यूजन पार्ट में जाए बाकी क्लास मेरा कंफ्यूजन क्लियर हो गया ना, दैट इज व्हाट यू आर मीनिंग क्लियर हो गया। ये पता है जब डिग्री आप कंप्लीट करोगे ना, जब आप डिग्री कंप्लीट करोगे ना, रद्दी बराबर फर्क नहीं पड़ेगा, इसको आप मत पड़ेगा। तो अभी से आप लोगों को बस क्लियर तो अपने क्वेश्चन को पूछना वैसे देगा मेरी सेंस हो जाएगा। ठीक है, तो your point is band limiting क्यों करते हैं? I think you got an answer to that because we cannot use infinite bandwidth or we don't have actually infinite bandwidth. वो 4-5 बजे निकलेगी। सुनो, so लेकिन एक important question, कौन सी क्लास है? टीचर का नाम? ठीक है जाएंगे एक मिनट. Listen to me. One point as an appetizer for the next class. That अब हमने तो डिसाइड कर लिया बैंड लिमिट करना है, लेकिन मसला है this is understanding that if I band limit the signal, what I am doing, I am actually telling you that leave all other frequencies. By band limiting I mean that cut this frequency and cut these frequencies and just transmit this much only. Oh, I will lose a lot of signal. Won't I lose a lot of signal? I will lose a lot of signal. But there is a concept of significant frequencies. Just write this word, significant frequencies. Significant frequency signals. Significant frequency signals are used, are identified. Significant frequency signals are only identified and the rest other signals are attenuated. Significant frequency signals are identified and rest all other frequency signals or frequency components are attenuated, or I would say limited, are not allowed to transmit. Because band limiting, we only allow significant. So you can just write this in another way. By band limiting a signal, by band limiting a signal, we only allow, by band limiting a signal, we only allow the significant frequencies to pass through the channel and attenuate all others. By, क्या बोला मैंने? By band limiting a signal, we, that's the one right now. We only allow the significant frequencies to pass through the channel or consume the channel, and all other frequencies are blocked. ठीक है? Okay, with that we stop.